All right, I'd like to welcome everyone back to the collision repair and refinish stage at SEMA 2022. And today we're going to talk about Jaguar Land Rover welding certifications. And with me is Dan Schwartz, and we're going to jump right into the presentation here. Dan, let's just talk a little bit about the certification we're doing at the Tech Center. We have the new Atlanta facility that we're also going out of with the training now, and just give everybody a little bit of an overview of what we do with that training.
Well, what we do, Scott, is we have a 5-day training session, and we also have a 4-day training for a reassessment. Every 3 years, the tech has to come back and redo their certification. But when we start this stuff, they come into the JLR facility either in Atlanta or Appleton, depending. But the one up in Appleton is where we're doing all the 5-day training right now. All right. So what we do is we bring them in on a Monday. We have a classroom session that goes through Monday, Tuesday, Wednesday, and by the end of Wednesday, we're out in the shop with them. We have 2 trainers per class because we have run a total of 6 people. Now, when you start, it don't sound like a lot of people, 6, but there's a lot of stuff involved with it. And these guys, when they come in, we're starting out with weld training a little bit to start out, getting them used to what they're doing, what they're welding on, the machines that we're using. And part of the reason we're doing that is because everybody has something different nowadays.
So, you know, the difference between the steel and aluminum class, they're very similar, but what do some of the technicians struggle with between the two of them?
Believe it or not, one of the biggest problems we have with the techs nowadays is steel welding, and that's because it's so different. JLR has very different specs than iCar. If you actually would do the JLR specs for the iCar training, you'd fail it for too much penetration. And they're not used to really putting a lot of penetration into the rails that we use. So it's a different mindset for them. And the older guys, like me, probably you, would have a little trouble with that because you learn a different way. So you're taking a guy and you're reteaching him how to weld, how to get a lot of penetration, because after you finish weld off, you got to have strength. So the steel is actually harder than the aluminum.
Yeah, and I think that's something that a lot of people just take for granted because steel is usually pretty forgiving when you're welding it. If your technique isn't quite there, you know, there's a little bit of nuance, but the level of detail that they go into, which we'll cover a little bit more later on, is pretty impressive of what they require for this certification. So we got the classroom set up here in the shop. So just give everybody a little bit of overview what that kind of looks like, what the typical day is.
When we get up on a typical Monday after we get everything signed in and everything taken care of, we start the classroom portion of class. And what we're going through is exactly what we're going to be doing, what a welder is going to do, how to set it up, what the specs we're looking for, and we'll do that, go through one portion of the class with just the welding, and then after that, it's usually about 2-3 hours in the morning, and then from there, we go down into the shop.
You know, and I think, you know, the big difference is there's practice time for this certification. So you're coming here to be certified. So it's not necessarily a training, the end result is a certification, correct?
Correct. Yes, the training time is not actually in the 5-day class. Now in the 4-day class, the actual test portion of that is 2 days, but the day and a half before is training. And that's where you can get in and help them and figure out what they're doing wrong.
So, you know, this is something we've talked about a lot, that, you know, body men are body men, they're not welders. They occasionally weld, and that's something that is really a challenge because welding takes a lot of skill and attention to detail. So just let's talk about a little bit some of how they can practice beforehand and what they should be looking at.
Well, you hit something right on the head there. They're body guys that weld, and one of the main things we have is when these guys come in, is the machines that they have today. You're not using your standard little Miller 211 or your little 140 Lincoln. You're using the Fronius machines, and they got a lot of voltage, a lot of amperage to them. So the machines all have a lot of settings on them. Well, a person that is not familiar with the settings on these things, we have problems because they don't weld long enough to understand what we talked about yesterday, all the background settings. But the amount of practice these guys do on them, especially when you're changing them over, you're going from aluminum. If you're in aluminum, that's fine, you're only aluminum. But in the steel class, you're running steel and MIG brazing on the same days. So it's a little bit of a challenge for these guys to remember exactly what they're all doing.
So how much practice do you recommend they do before even showing up? Because, you know, you don't ever want to practice on a car, but, you know, what should they be doing ahead of time before they even arrive at the tech center?
Well, that's one thing that we do is we can take, they can go to actually our supplier for steel, and they can get actual pieces that we use in class for practice. That helps a ton. But one thing that does happen is a lot of guys, if they're not practicing right, that practice can also hinder them. So one thing that we're lucky on, because there's 2 techs, a minimum of 2 techs for every repair facility. So if a guy has been there already, they usually can coach the guy through a little bit, so what to expect, because it's a very high stress environment for these guys when they come in.
Well, yeah, because this is just like test day when back in high school, and people have test anxiety, and there's pressure on it because now, you know, this is to do with your job, and I think that's something that a lot of technicians seem to struggle with that pressure level.
I think it's even a little worse, because when you're in high school, when you went to school and had a test, you had to answer to your parents if you did bad. Now you got a guy that's paying your check. And it's not, like you say, it's very expensive for these guys to go through there. But the amount of skill that it requires, they need to really practice and really keep their head in it. They have to really pay attention to detail. And a lot of the guys nowadays that are a little older, I think the average age of a person in class is right around 45 years old. There's not a lot of young techs coming up. And the old dog, new tricks things, it sort of plays in there a little bit.
So let's just talk a little bit about the actual pieces that we have here. So this is the aluminum structural welding certification. And let's just kind of give the audience a little bit overview of what the technicians are actually expected to do here.
On that particular piece there of aluminum, that is the 5-day steel or aluminum test. What that is a 3-piece rail and what it is it mimics a rocker. So they're going to do SPRs on there. They're going to do brake stem fasteners. They're going to be doing plug welds, butt welds. Also, they're going to be doing lap welds on there. This is done in 3 stages. So one day we'll do one part on it, because one of those seams on there is glued. There's an adhesive on it, 8115 or 7333, nothing different. Then they'll take it, they'll get it all ready after they get it glued together, and they'll put it back, let it down, everything dries one day. The next day, it's when they come in, they get another piece to it that's a top piece. That top piece is a replacement. So this is like when a vehicle comes in and needs to be repaired, cutting it, repositioning your new piece, and moving on from there.
So they're truly having this to be a simulation of a repair procedure. And, you know, what about like the placement of the rivets and the location of the welds? How critical are those tolerances that they give?
Well, we do have everything marked out, and there is a pitch on the SPRs where you have to have, and that goes according to thickness or whatever they have in there. All right. The rivets are all, when you replace it, because when one comes out, one has to go in. You got to keep them consistent. Everything goes on the left side, the right side, whatever it might be. So that everything has to be placed back where it is.
And so these are kind of prefabricated pieces. And let's just spend a little bit of time talking about how many different attachment methods you're actually using. So you mentioned the rivets and the bonding, but what about the plug welds on an aluminum piece?
The plug welds in there, everything has a backer behind it. That's just to support the weld. That's why you're putting a backer in there. Believe it or not, when you get into these things, the plug welds are the hardest things for guys to do. Because one thing that we do with JLR, they want you to have a really good grasp on what you're doing. So when we're making up, before we get to this piece here, we're putting coupons in a box. We're making them with lap welds, plug welds, and butt with backing. Now, to get them the heat mark, they don't want you to put too much heat in anything nowadays, all right? So the heat marks, you're checking on the back. You want a weld to lay out flat, but yet you can't have it too hot. And that's where you take a guy that's, when we set up a machine or they set up the machine and we're checking out with them, you have to have that person, once you find out their technique of how they're doing it, to adjust the machine to them. These machines are so, you can adjust them to do almost anything for you. So what they'll do is they'll get them set up, and then you try to go to their technique. It's a lot easier to change the machine than change their technique.
Well, and that's where, we talked earlier in this week, with aluminum welds, it's so different because it starts out so cold and then it goes so hot and it dissipates the heat, and so controlling that, especially on a very small plug weld, is a challenge.
It's a big challenge, and the machines that we use are all sinker pulse. So, and we got hot start set up, and there's a trigger system in there where you can go a 4-step trigger. You can do a special 4-step where you're just holding onto the trigger and the machine makes all the adjustments for you. And what we did, we went to some of these different methods depending on the guy welding and how, if he stays in his head yet, because they are very nervous when they do this. But we had guys already that put it in hot start, and when they're supposed to let off the trigger, if they don't let off, you're running your piece in hot start. What happens? You blow holes in it because it's too hot. You can adjust it a different way where they don't have it, where everything is automatically. Will come on at the hot start, it'll slope down, you run your weld, it'll go into your creator, fill the whole bit for you. And JLR also, when we do anything with there, we have to have run on and run off tabs. So you do not have to use a hot start if you don't want to, because your heat is made before you even get to your joint.
So steel structural welding certification, so we mentioned the MIG braze and the steel. Let's just talk a little bit about what goes into this piece.
The piece is actually identical to the aluminum piece, but it is steel. It's 22 gauge steel, and this here is very challenging. Now you're doing two different welds in here. You're doing a MIG braze, you're doing a slot weld, and you're also doing an open butt, and you're doing a plug weld, and you're also doing an open butt with the steel.
So what is the biggest challenge with the MIG brazing? So is it the actual weld joint, or is it the slot welds?
Both.
That's a pretty easy answer.
Yes, and here's why. Because when you do a slot weld, now you're doing a slot weld rather than a plug weld, so you got more surface area, so you get more flow underneath, so it holds the pieces together, right? And you're doing that, and you want to have a short stick out. And the reason you want it short is you want it a little hot, but not too hot, because you don't want to burn through, right? All right, but you want it to lay out. And these things, the biggest complaint we hear, people, it looks ugly. It looks ugly. They're not the prettiest weld that you're doing, but you are going to be preparing them, so you're going to be grinding them off. The thing is, with them, you got a short stick out. With the Fronius machine, when we do that open butt, we have a stick out that can go up to 2 inches. And people look at you like you're nuts. But that is where you're getting your capillary action on the back and really helps it push through.
Well, and I think that's something that kind of comes from people being used to regular steel welding and things like that. That kind of a stick out would be a hard adjustment for me to make, I think. So let's talk a little bit about the steel welding, because I think a lot of people look at that and they think, we've been welding on steel cars for however long. What could possibly be challenging about that?
Well, when you have a class with all older guys in it, one of the biggest challenges is the technique we're going to use, because most of them would pull a weld down. We don't do that. This is all done in a stitch method, which is on and off, on and off, on and off. We do that for two reasons. On an open butt joint with MIG braze, I can't do it, and I've been doing this a long time. I could not make a open butt with the MIG braze and not have a flaw. We are allowed one flaw over 3 millimeters combined with the slot and the open butt. That's all that they are allowed. So you have to really take your time. You really have to hone in on what you're doing and watch what you're doing. Eyesight's very important. You have to be able, when they cut their piece, preparation, very important. They got to make sure that, remember, when you're on MIG brazing, it's a non-fusion product, all right? So what happens is on the MIG braze, if you don't clean the joint up and back and you got a little piece of steel on there, what it's going to be? It's a dam. Why? Because you're not melting that. And it'll hold it from your capillary flow on the back. So there's a lot of small things that you really have to pay attention. Your wire placement, very important. Your capillary action on the back from 1/2 to 2 millimeters. You want to be consistent. You want to make it look good. When you go into corners, very hard to manipulate. You have to really pay attention where your placement is the same every time. Eyesight's so important on there, because if you can't see where your wire is being placed, you're gonna really struggle with it.
So, I see on here we call out the 5 millimeter plug welds. And I think that comes down to the fact that the pinch weld flanges seem to be shrinking dramatically. Weight savings and the look of the vehicle, whatever happens to be. So, what are some of the kind of things that we are looking for on that 5 millimeter plug weld hole?
That 5 millimeter plug weld is a challenge. Believe it or not, most guys go, I've never done one of these in my life. And the problem when you do a 5 millimeter plug weld, when you're on something that small, you're putting your wire placement in the middle of the hole, you're pulling the trigger and you're not moving, you're letting it fill up. Because also when you're getting that 5 millimeter plug weld, you also have to have a 1/2 mil to 1.5 mil of penetration on the back. Believe it or not, when we do our steel test, one of our biggest failures for people on the test is lack of penetration on a plug weld. And you're allowed one miss. So if you get a plug weld mark, everything else has to be perfect. Your open butt has to be perfect, and the rest of your plugs.
All right, so now it looks like we're going into a little bit on the spot welds. So they're even testing spot welds on this project.
Yeah, what we get into here is panel preparation, and you got to have the right spot welder to do the job for you. And nowadays with the smart welders out there and stuff like that, everybody thinks just grab it and go. Well, they actually like you do these in manual mode. So you have to go in there, figure out where you're going to set this thing up, where you're going to set your squeeze time, hold time, cool time. Try to get everything set. A lot of people will go, why do we do that? It's an option so you learn the welder and learn how to use it, all right? These welds on here, there's a 7 millimeter minimum, and to get that minimum, you have to have a big enough tip. Sometimes your tips are too big, too small, and you got to figure out a little more force, a little more time, whatever the case may be. One of the big problems they have with these things, and like you're talking about lack of space, if that car comes back in that shop for the second time and has to have another fender put on, when you run out of space, you don't repair the flange, you go in farther. So you could go from the second repair, from a repair of just replacing a fender, to be going the inner wheel well and keep going until you find you got enough metal again.
Okay. So let's just talk a little bit about how detailed of information that JLR is actually looking for as part of that certification.
This here's a picture of the welds that are actually done on a rail. And what happens is after we're done with the test, we take them, we cut the rail open, we tear them apart, we scrub them down, and there's pictures taken of every position. And these positions are taken in high def. When we're done with them, they get sent to we grade them out. We're looking for one flaw over 3 millimeter, or if a guy misses 2 plug welds per se, or whatever, it's reassessment time. But when we take them, we get all the pictures, we take them, we grade them out, and then everything's sent to the UK. When we send everything to the UK, they give us the final. He checks all of our work over again. If he's okay, I get the email back with a smiley face, and if they question it, we might have to pull somebody back in. But that usually don't happen. We're very stringent on these things. And the worst part about something like this is you get these guys that come in and you develop a relationship with people. I mean, I had guys in there, so I've been doing this for the last 10 years, 12 years. And these guys, I've seen them 3, 4, 5 times. You become friends. And what's good about it is they still understand you have a job to do and they have a job to do. Because it's very hard. I mean, it'd be like failing your own kid. It's very hard to do once in a while.
And I think that really comes down to, though, the level of detail that the OEMs expect from collision repair technicians to repair these vehicles in a way that they're going to perform as intended in a collision. And anything that we do can really affect that. And if you have a hard time doing it on here, a vehicle where you have all the adhesives and all the other contaminants, I think that's another huge challenge that they're trying to bring up the level of skill for that technician. So on the vehicle, it's a little bit better.
Well, yeah, JLR has procedures for everything. If there's not a procedure, it's an unapproved repair, regardless what it is. You know, it could be something, well, I know I can fix it there. If it is not an approved repair, you cannot fix it. If you do, you take total responsibility for something like that, and you could be kicked out of the network for it. You know, the techs that we get should be like the top 10, top 15% in the shop. So they're looking for the best of the best. The thing is, a lot of people go, well, that's not real. Why do we have to do that? I wouldn't have to do that in a car. Why? They're not concerned about of that question at all, because they want you to be above and beyond what everybody else is. We've had people come in and question us like, man, this is the hardest test I ever took. It is. I'll agree with them. I mean, the first time I took it, I failed it, not understanding exactly what to do and how to get where I need to be. But when these guys come in, we put them through the ringer on there, and they work and work and work. And there's times when we come in there for a retest day, or for even the rail, they'll be working on one particular part of a weld for a day, day and a half. And it sounds pretty easy to say, well, run an open butt there, like on that on the steel there. We're looking for 1 to 3 millimeters of penetration in the back. That don't sound like much, does it? That's 3 times as thick as the steel you're welding on. That is a lot. Nobody ever has to do that. But when you do that and you maintain that, you know that joint is not going to fall apart. And in the stitch process that we're using, you're not dumping all the heat in there, because you're stitching it rather than running it as a continuous bead.
Well, and you know, I think that's something that a lot of people don't think about is, you know, that penetration that they're looking for. When you grind the top side of the weld off, that's where your strength is coming in. And so it makes sense that, especially on like a MIG braze, if you didn't have that and you don't have the capillary action, you actually don't have a weld.
With MIG brazing, you wouldn't have a weld anyway because it's non-fusion. But no, exactly. And you have to have a lot of penetration on the back. You can have the point that you have too much also, all right? But like you say, once you clean that weld up and make it nice and shiny and nice and flat, it's complete, you know, but you got to have something on the back. And a lot of people, once they learn to use the MIG brazing, they prefer to use it a lot more. But there are procedures that are called out, and you can only use it where they're telling you to use it.
So let's just spend a little bit of time diving deeper into the causes of the failures here. So first one up there, eyesight deficiencies.
Eyesight, yeah. When you start getting a little long in the tooth, your eyesight seems to go away fast. People, one thing they don't realize is when you are welding and they go, well, I got my readers on. They'll put their readers on and go, they're reading right here. When you're welding, you're not reading here, you're reading right here, or you're welding up here. So if you have a 1.5 cheater, you might be up to a 2.25, whatever. You have to see close. One thing I found out with the guys that are in our industry, they're pretty proud, and they don't like to wear glasses or be told they need glasses. So one thing we'll do is I'll walk up to somebody and watch them, and pretty much you can tell right away if they can see or not. And if they can't see, and if I think they can't see, I'll put something on my phone and hold it in front of their face real close right away. And the first thing they do, if they start backing away, I know they're not seeing close. And then I'll tell them, this is why I did it. You know, try a pair of readers, just humor me. I had a guy one time come in and he goes, I don't need them, my doctor, I just went to the doctor, and he says, I got 20/20 vision. That was fine. When I put the phone in front of his face and he backed up, he goes, well, I can't see it that close. I go, you need readers. And he goes, well, my doctor said, what do I do? I mean, I just went to the doctor. I says, I'll get a different doctor. But he put on readers, and you would have not even thought that was the same guy welding. It improves that much. You got to be able to see it. There's 2 things you got to have. You got to have a steady hand, and you got to be able to see. If you can't do both of them, you're gonna have a lot of problems.
So any final thoughts before we wrap up today?
No, it's just you know, this industry is lacking from a lot of young people. And there's an opportunity here for young people to really get into it and absorb everything you can. There's going to be a time when the older guys aren't going to be there to learn from. That's why they have all the procedures, and they're laying everything out for the guy to make sure that you always have somewhere to go. And through ICAR training, through any kind of training out there, some is better than none. Don't be afraid to get into it, and don't be afraid to fail, because there's a lot of people that are out there that they're terrified of failing. And that, you know, once you're taught and you retain it, you're usually pretty good. You can always come back to it. But that is one of the biggest things out there, get trained.
All right. Well, thanks, Dan, and thank you for everybody that joined us, and hope everyone has a great show.